Welcome to lesson 3.15, Applying Cryptography. We're going to be focusing on crypto attacks. In your candidate information bulletin, we are in the security engineering domain, and we are in a key area of knowledge I, which is applied cryptography. Our topics are going to include cryptographic attack models, key attacks, hash attacks, network attacks, and algorithm and protocol weaknesses. This is the last of the lessons that are specific to cryptography. So cryptanalysis is the science of cracking codes, decoding secrets, and violating authentication schemes. And most importantly, finding and correcting weaknesses in encryption algorithms. Cryptanalysis can be used by the bad guys or the good guys to crack codes, decode the secrets, violate an authentication scheme, or find and correct weaknesses. Cryptographic attacks can be classified based on what type of information the attacker has. The attacker always has to start with something. So there are really four models. One is ciphertext only. Remember, ciphertext is text that has been encrypted. So in a ciphertext only attack, a sample of the ciphertext is available, but no plain text is known about it. So they just have the encrypted information. In a known plain text attack, there's a sample of the ciphertext and corresponding known plain text is available, but it's just a sample. In a chosen plain text attack, the attacker can choose the plain text to get encrypted and obtain the corresponding ciphertext. And in a chosen ciphertext, the attacker can select the ciphertext and obtain the corresponding plain text. So those are really our four types of attacks that we might see in a cryptographic environment. So we're going to look through very specific attacks now, starting with attacks on keys. So the goal of a key attack is to discover the key value. There are three primary types of key attacks. The first one is a brute force. And the brute force says, I'm going to try all the key combinations until the correct key is identified. It means we're just going to keep going and keep trying and keep trying. A brute force, given unlimited time and resources, will succeed. But that's very often the case. A brute force attack is limited by time and resources. And in modern cryptography, we're referring to processing resources. A frequency analysis is looking for patterns. It's looking for words that we use over and over again, like and that, is, hello, and then certain letters that are used more often than others. ETA, ONRISH, that's not a word, those are individual letters, are the most frequently used letters. So we're looking for those type of patterns in order to reverse engineer and discover the key value. Differential cryptanalysis, also called a side channel, measures exact execution time and the processing power needed to determine the value of the key and the algorithm used. So our three attacks, going in order of complexity: brute force, then frequency analysis, then differential cryptanalysis. We have two primary types of hash attacks. The first one is collision, and the goal of the hash attack, particularly a collision attack, is to discover the plain text. Collision attacks are based on the premise that collisions are unavoidable when members of a large set are mapped to a relatively short bit string. Remember that we're saying that we can take a string of any length and put it through a hash function and end up with a fixed length output. So in the collision attack, we're saying that we probably will end up at some point with collisions when we've got lots of strings that we're mapping to, but we've got a relatively short output, the short bit string. At some point, they should start colliding, meaning that they should have the same output. So a collision occurs when there are two distinct pieces of data have the same hash value. Now, the most famous of these attacks is what's called the birthday attack, and it employs the birthday probability to produce collisions. The birthday paradox is the probability that it's greater than 50% chance that two or more people in a group of 23 share the same exact birthday. To avoid this attack, the output length of the hash function must be large enough so that the birthday attack becomes computationally infeasible. The second hash attack is the dictionary hash family. In a dictionary attack, uses a file which contains words and phrases and common passwords and other likely strings. And each word in the file is hashed, and its hash is compared to the target hash to check to see if it's a match. A hybrid attack actually builds on a dictionary method by adding numeric and symbolic characters to the dictionary words, as well as substituting numbers and symbols for letters. So example, the word password might become $, capital W, 0, RD. So again, the goal of the dictionary attack is to say, let's take all of these words and hash them. We'll get the hash output. We're going to compare them against the target hash output, and if one's the same, we'll know what the original information was. Very often, dictionary hash attacks are going to be used against password repositories. The goal of a crypto network attack is to exploit weaknesses in the communication protocols and transmission methods. So a man-in-the-middle attack involves intercepting and forwarding a modified version of the transmission between two parties. If we just took a message digest, and the message digest that wasn't a digital signature or didn't have an HMAC was captured, the message could be changed and retransmitted along with a new message digest. So we want to make sure that the man in the middle doesn't have the opportunity to do that. A replay attack involves capturing and then retransmitting a legitimate transaction at a later time. And a traffic analysis attack is used to reveal information based on message volume and communication flow, or just to identify the communicating parties. As computing becomes more and more powerful, the mathematical strength of algorithms and keys weaken. As computing becomes more powerful, the mathematical strength of algorithms and keys weaken. Example of protocols and standards that have been weakened include DES, Triple DES, MD5, and WEP, Wired Encryption Protocol. In addition to mathematical strength becoming weaker, we're finding that over time, protocols or cryptographic library flaws are being discovered and identified. Really, those flaws I want you to think of as weaknesses or vulnerabilities. Recent examples include the Heartbleed bug, Poodle, Shellshock, and Freak, where weaknesses in the protocol or in the cryptographic library have been identified and exploited. So let's review these attacks. We talked about the cryptographic attack models, which start with what type of information the attacker has. We looked at key attacks, which included brute force and frequency analysis. We looked at hash attacks, including birthday and dictionary attacks, network attacks, including man-in-the-middle, replay, and traffic analysis, and then algorithm and protocol weaknesses. These are all attacks that you want to be able to identify and recognize. So let's do a match the meaning. We have a side channel attack, a brute force attack, a frequency analysis, a collision, a birthday attack, a man-in-the-middle, MITM, a replay attack, and crypto retirement. Now, we haven't used all of those terms, but you should be able to apply them. Put me on pause, take a few minutes, match up the meanings, and then come on back and we'll talk through. Welcome back. Let's look at lesson 3.15 terms. That side channel attack measures execution time or power. A brute force attack is exhausting all possibilities. Remember, a brute force attack is only limited by time and resources. A frequency attack is looking for patterns. That's patterns of words or patterns of the most used letters. A collision happens when different input results in the same hash value. A birthday attack exploits the birthday probability to produce collisions. Man-in-the-middle is when we have interception and modification. That's the goal of man-in-the-middle. A replay attack is when we capture information and retransmit it at another time for a different use. And lastly, crypto retirement, DES for example, which is what happens when we see that a standard or an algorithm has weakened to the point where it is no longer usable and secure. So we're going to end this unit by looking at our CISSP exam tips. The first is that work factor is an estimate of the time and the effort it would take an attacker to penetrate or break a crypto system. Cryptanalysis is the science of finding and correcting cryptographic weaknesses. And as computing becomes more powerful, the mathematical strength of algorithms and keys weaken. That's why we see various standards and algorithms being retired over time and new ones taking its place. So thanks for joining me for this lesson. We're going to move next into looking at physical security. So we're going to spin your head around and leave cryptanalysis and cryptography behind and go into the world of physical security in the next lesson. So I look forward to seeing you there.